Hi everybody, this is Dino Chris from Prehistoric Facts, and hey, we got some questions here for today for answering questions for this answering questions episode for Prehistoric Facts. So let's get right to it, shall we? This is from Tanner from Austin, Minnesota. Is it true a T-Rex skull is as hard as diamond? Well, I looked this up, and the answer is no. And reason why is because you see, when fossils are actually formed, it's basically minerals that are actually coming in basically from the rocks or otherwise the groundwater that actually kind of go inside the bone to actually make the bone harder and actually make it durable in the rock. But basically during fossilization, any kind of minerals can actually get inside the bones. Basically, most of the time, the minerals that actually get inside fossilized bones, in particular, are pretty much iron and some silica, and basically, that's basically most of the minerals that actually get in the fossils, and that's that's all, but basically, yeah. Sometimes quartz can actually get inside some of the bones of prehistoric animals. That's just part of the fossilization process, and also, but basically, like some marine animals, I've seen marine fossils actually been opalized. They've been turned into opal, and that's pretty amazing. I mean, when I was at the Field Museum, I got to see pretty cool thing that I never thought I would get to see, and it was basically in the gem hall. They actually had a plesiosaur vertebrae that is just basically opal. It was opalized. I mean, that's just amazing. And so it's basically any mineral can actually get inside a fossilized bone, and basically T-Rex, in terms of the minerals that actually got in the bone, is basically just iron and some silicas. And iron and silicas are not as hard as diamond, and diamond is the hardest mineral on Earth. And so you're not gonna break it very hot. You're not gonna break it very often. You need some pretty powerful tools in order to actually break the diamonds, and so that's not really going to happen. And so basically, most fossils are just very fragile. They're very, very fragile, and that's basically how they are. It's because it's very fragile rock, and sedimentary rocks don't actually hold crystalline minerals, and so that kind of actually don't, because that usually is pretty hard to do. I mean, quartz can actually get into sedimentary rocks. That's actually one occasion. And also, calcite is actually in some sedimentary rocks, mainly limestone. But basically, basically where T-Rex has been found, it's basically found in sandstone and siltstone. That's basically just all basically terrestrial life deposits, and so that's basically just rivers, and possibly just a river that actually just was flowing through that particular time to actually kind of actually bury the fossils, and also kind of put in the minerals that actually kind of get into the bone. All right, next question from Madison, and no, but basically just Madison right now, but no city or state basically, but that's okay. How can it be proven that what dinosaurs look on the outside when all scientists have is their bones? Examples: color and outside skin. Also, what killed them? And okay, so two questions at once. So that I can handle. To the first question, how do we actually find out what dinosaurs probably look like, but all we have is bone? Well, basically, there has been actually there's actually been skin impressions of dinosaurs that have been found, but it's usually just a trace fossil. It doesn't actually it's not actually the actual skin. It's just basically just an impression of the skin that's actually just been preserved from when the animal was buried. Basically just buried when it was actually almost on the decomposition process, or otherwise it was actually buried very quickly, but basically the skin just rotted away. Probably when it was inside the soil or the mud, and then basically that skin just totally basically just rotted away, and basically the impression of the skin was just left. But there's also been mummified skin of dinosaurs. It's very rare, but hadrosaurs and ceratopsians have been found with mummified skin, just skin that was fossilized, and we can actually give an idea of what these dinosaurs probably did look like. But color is very difficult in terms of skin. But even though scientists have actually done some research, and basically they looked at a dinosaur that is that was found in China, and what they did was they used a particle microscope, and basically look right at where the feathers of the feather impressions, and basically what they found is basically the pigments of those feathers, and you can see them under a microscope, and also in a electron microscope. And so basically that's just an amazing thing. And what they found is that this dinosaur is actually black, white, and sometimes reddish brown. Have reddish brown feathers, and that's the only dinosaur that's been actually known to know by its color. But it's very rare to do it, and also it's very hard to do it on some fossils. It's because sometimes we don't know if the pigment of the feathers has actually been preserved quite well enough. But luckily, the Liaoning formation in China is actually just an amazing formation of rock that actually just kept some of the soft tissues fossilized, and also how most of these animals are actually complete in terms of their fossilization of preservation. And so that's amazing to actually think about that. And so color we only got one dinosaur that's been colored. I believe it's called Anchiornis. I think it's called Anchiornis. But even though it's still up for debate on whether or not what the color of dinosaurs were. But basically, just look at because since the theropod dinosaurs, basically the meat-eating dinosaurs, their descendants are actually modern birds. So when you actually try to think about what color they might have been, probably look at some modern birds, and actually think of what could their color have been, I mean, if you look at a peacock, male peacocks actually have very colorful feathers, whereas the females, they don't really have that much of color because they have more duller colors. That's why most male birds actually have brighter colors. It's because they need to advertise to the females, and also if males actually were competing over females or territory, they probably actually had to display their feathers to actually say, I'm the brightest and the healthiest male, and also I'm tougher than you. And most of the time theropod dinosaurs actually go to the extreme of basically they actually fight each other, just basically biting each other, but mainly just facial injuries. Sometimes they would kill each other sometimes, but that's pretty rare in terms of predators. But if you wander in somebody's territory, that person is going to be mad. So there's a lot to do with that. And also your second question too, what killed the dinosaurs? Well, basically during the KT extinction, which is basically that period where that point in time and you can see in the rocks of the Cretaceous and the Paleocene rocks is basically there's a very thin layer is where it's like a clay-like material that's actually in the rock, and that's called iridium. And that actually, iridium is very rare on Earth, but when you actually look at iridium on meteorites, they're very, very common. And so that element, iridium, is actually a very good indicator that shows that a meteor strike actually happened. But it wasn't until 1980 they actually said that something major happened, and it was actually that content of iridium that has been found almost all over the world during that ending period around 66 million years ago. And it wasn't until 1991 when satellite imagery and also oil companies that actually were trying to search for oil in the Gulf of Mexico they actually found what appears to be an impression of a crater, a meteor impact crater at the Yucatan Peninsula, near the Yucatan Peninsula. And so that actually shows that there was a meteor strike that actually happened during the time of the dinosaurs. And so that actually gave the kind of smoking gun evidence to actually say, yes, a meteor strike actually hit the Earth, and it actually caused the extinction of the dinosaurs, possibly caused the extinction of the dinosaurs. But they didn't really know the size of the meteor impact until they actually did satellite imagery of the ocean floors, and they actually saw that this impact crater was so large it would actually have to take a large meteor to actually cause that kind of impact crater. And the meteor impact crater is actually over 100 miles long, and it's over 100 miles in diameter. And so that's impressive. That's impressive for a meteor. And basically, how big of an asteroid or a meteor that you actually need to make an impact crater? Well, they actually estimated that meteor was probably 6 miles wide. I mean, that is a large meteor, and that meteor is basically the size of Mount Everest. So if you just basically cut Mount Everest off a globe and you threw it at the Yucatan Peninsula, you're gonna have a big honking crater. And so it's a really big crater. It's visible in satellite imagery, but basic in terms of the ocean floor type of satellite imagery. But when you actually try to see it visibly on there, it's basically eroded. It eroded throughout time. And but also there's still debate on whether or not if that was really the cause of the extinction of the dinosaurs. Some scientists still believe that the Deccan Traps in India, which is basically a form of basalt rock, which is basically flood basalts in India, have actually caused like these toxic gases to actually spread around the world. But there's still a lot of holes in that theory. One is basically that this kind of flood basalt wouldn't have actually created that many gases to actually go in, to actually kind of basically get into the atmosphere. You know, like carbon dioxide and sulfur dioxide. I mean, those are gases that you don't want to mess with in terms of the atmosphere. So that actually kind of possibly might have happened, but it did happen. But it's still up for debate on whether or not if those amount of gases would actually have caused basically some like a global extinction. But I think probably what was basically the meteor impact was basically the number one catalyst of actually say that a meteor impact caused the extinction of the dinosaurs, and then basically the events after the meteor impact actually caused the extinction of the dinosaurs. There's still debate on whether or not some dinosaurs have actually survived. And I believe there might have been some dinosaurs that survived the day of the impact. You know, it's just that of like how long would they have actually lived after the impact. I mean, it's still hard to figure out. We don't know if they lived like maybe like a year, or maybe 10 years, 100 years, 1,000 years, a million years. We don't know, and so that actually is still up for debate, and that's always up for debate of how long dinosaurs probably might have survived after the meteor impact. So, meteor impact, a meteor strike has actually caused the extinction of the dinosaurs mostly. So it's still, I mean, you can look up anywhere on the internet and you actually still see like the Deccan traps possibly caused it, and the Chicxulub crater of a meteor impact caused the extinction. So that actually is still going on, but it's still basically a meteor impact probably caused the extinction of the dinosaurs. Alright, that's it for now. So next week we'll actually have a special episode on Saturday. So back to a Saturday kind of rotation. And this time we'll actually kind of talk about Raptor Rex. Somebody actually posted a comment on one of my videos and actually thought like, why not actually talk about Raptor Rex? So you know what? That'll be the dinosaur that we'll be talking about next week, Saturday on the 11th. So that actually will be pretty awesome. So and also, if you still have a question about dinosaurs or other prehistoric life, feel free to email me at dinocris71@gmail.com, or otherwise you can post a question on the Facebook page in the comments section, Prehistoric Facts with Dino Chris. Follow that Facebook page, and hey, you can post questions anytime. Email and Facebook is open 24/7. And also you can follow me on Twitter at CSGRALL. And so you can follow me on Twitter, post some cool stuff there. And also take care of the people around you. And also for younger people out there, make sure to listen to your parents, your teachers, and your guardians. Those are the best motivation you can have for a good education. It's very important to have a good education. With a good education, you get a good job in the future. Alright, that's it for now, and I'll see you guys next week, Saturday.